Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 3C. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Conference on Information and Communication Technology for Intelligent Systems ICTIS 2024, Ahmedabad, India. The 8th edition of the conference is being organized in a hybrid mode. The physical event was organized in Ahmedabad, India on the 4th of April 2024. And the virtual event is being held through Zoom today, that is the 5th of April 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes each for the presentation and 2 minutes for the question and answers. On 7 minutes, I will raise a gentle reminder. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to our session chair. Our session chair, Dr. Rachna Sable. Ma'am, ma'am is working as an assistant professor and HOD at GH Raisoni College of Engineering and Management in Pune, Maharashtra. She has total of 17 years of experience. Her area of expertise lies in machine learning, deep learning, natural language processing, computer vision, and statistical analysis. Now we can start on with the presentations for the day. I would like to call Mr. Sunil J.S. for his paper titled A Study on Operational Techniques of Preliminary Refinement of Images in Camouflaged Enemy Detection. So, can you please start with your presentation?
Yes, ma'am. Thank you. Good afternoon. 1 minute, I'll share my screen.
Okay.
Good afternoon. Good afternoon, everyone. I'm Sunil Jays. I'm research scholar in NMIT, Nitya Meenakshi Institute of Technology, Bangalore. My paper title is A Study on Operational Techniques of Preliminary Refinement of Images in Camouflage Enemy Detection. The contents are abstract, introduction, literature survey, problem definition work, proposed work, methodologies, observations, comparative analysis, conclusion, differences. The first, the abstract. The abstract, this study delves into the pivotal role of image processing in defense systems that is crucial for identifying images. As you all know, defense systems mainly works on image processing techniques that to identify threats, and we are implementing. This is this is a survey paper. We are gathering as much as knowledge available. Image captured over a wide range of terrains, introduced specific challenges and possibilities for precise target differentiation. For example, if we consider the terrain of Indian border, it consists of forest, deserts, and ice terrains. Some of the techniques some of the pre-processing techniques are resizing, normalizing, and edge detection. Results showcase enhanced algorithm capabilities in detecting advisories. The study also discusses various techniques influencing image analysis and their utilization across multiple computer vision domains, offering insights into the effectiveness of the proposed pre-processing methods. Next, the introduction. In introduction, the image pre-processing is an essential part of image analysis and computer vision, as it is crucial in enhancing the quality and interpretability of the images. As we also know, image processing is a crucial in diverse domains such as defense systems and medical imaging. Detecting camouflage enemy requires sophisticated pre-processing techniques like contrast enhancement and texture analysis, which are important for identifying camouflage in objects or threats. Pre-processing integrated with advanced technologies like deep learning enhances detection capabilities. In the literature survey, in the first paper, we will concentrate on the edge. We have surveyed about the edge detection uh, in the paper title named camouflage detection using image processing. In the second, we focus on normalization. Then in the third, we focused on various pre-processing filters like Gaussian filters, statistical filter, and median filters. In the fourth paper, we have concentrated on noise removal and image enhancement techniques, and so on. The problem definition involves the pre-processing images to extract features of camouflage enemy, enhancing the visibility of potential threats and locating the camouflage enemy in the terrain. By improving image clarity, uh, identifying features and classifying terrains is the main aim to optimize the threat detection in the varied environments. As we know, there will be low visibility in the forest terrains as it will be dark. We should train the model as per the requirements. And this is the methodology. For the problems to enhance dark images, we have surveyed and we have implemented. We have considered the techniques of histogram equalization, which enriches contrast by redistributing pixel intensities. Next, for the deep network to accelerate deep networking training, we have introduced normalization. Normalization renders images and it will normalize the images into certain range, or uh, it normalizes images into the certain pixel values of a common scale. In the next, we implement noise reduction techniques like deep learning based denoising algorithms or techniques to eliminate noise contributions to enhance the image quality. Next is vegetation removal. It removes the forest area or trees in the unwanted vegetation in the picture. In next, the techniques of thresholding helps to improve information technology for a person identification by occurred images. It segments an image into regions based on pixel intensity values. Next is texture analysis. As we are concentrating only on RGB images, it's important to have texture analysis as it extracts meaningful information about the patterns to enhance features representation, and it also improves the performance of the subsequent image pre-processing. And the next is we consider canny edge detection techniques also as a to minimize the noise and extract useful insights. Next is augmentation. As we know, we get less data set when it comes to security domain. So we have implemented, we have considered the image augmentation technique to increase our data set. The observation is, as we have saw various techniques in methodology, the observation is we consider to what we have selected methods like adaptive histogram equalization, which enhances the dark images, which is an updated version of histogram equalization. We have considered batch normalization methods that increases deep network training, and wavelet transformation for effective noise reduction, and QCC quasi connected components for thresholding on structures with uncertainty or ill-defined boundaries, and color space transformation. As I already mentioned, we are considering RGB images. It is uh, it's important for us to consider the details in the colors of the images to detect the targeted enemies. In comparative analysis, we have compared both histogram equalization and adaptive histogram equalization. The success parameters of adaptive histogram equalization over histogram equalization are local adaptation, handling varying illumination, and artifact.
Excuse me, sir. Just a gentle reminder that 8 minutes are over. Can you please wrap up?
Okay, these are uh, these are the other uh, uh, advancements we have considered and compared. In the conclusion, implementation of various image processing techniques that include text analysis, color space conversion, and machine learning integration has significantly improved camouflage enemy detection. These methods enhance image features and mitigate impact of camouflage, leading to higher detection accuracy. Comparisons with existing models highlight the unique contributions of implemented techniques, addressing challenges and limitations such as data constraints and variation in camouflage types, informs future research directions and ensure methodological rigor. And these are the references. Thank you, ma'am.
Sunil sir?
Ma'am.
Yeah,
Yes,
I
ma'am.
just wanted to know what is the size of the various data set that you have gone through while doing this survey analysis?
Ma'am, as this research wants
Yeah,
camouflage enemy data set, as it
yeah.
is a
So
survey
what was the,
paper. Okay,
yeah,
ma'am.
you have done the survey of this paper, na? You have presented an analysis. So
Yes,
you
ma'am.
said that the data set was not that readily available. So various data, image augmentation and all has to be done.
Yes,
So
ma'am.
what is the size of the data set that you have gone through during this analysis?
Ma'am, we got a data set of the size around 600 to 650, ma'am. After
Okay.
the after argumentation, we can probably do 1,800.
Okay. And what are the various deep learning methods for this image pre-processing and all that will help you to get more optimized results?
Ma'am, we haven't implemented deep learning techniques, but we have
No, no, but
implemented
you have, yeah, while review you might have gone through, na? What are the
ma'am.
existing methods for this?
Okay, ma'am. We have implemented denoising, deep learning denoising algorithms. Means
Okay.
we have implemented deep learning techniques only for noise reduction algorithms. Let's say.
Okay. 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 ठीक है sir. Thank you.
Thank you.
Thank you, sir.
Thank you.
Now we can move on to the next presentation. I'd like to call Mr. Benjamin Jacob for his paper titled Automated Signal Responsibility Principle Enforcement, a step towards reusable and maintainable code. Sir, can you please start with your presentation?
Yeah, sure. Is my screen visible?
Yes, sir.
Good afternoon. I'm Benjamin A. Jacob from Christ deemed to be University. I'm a master's student in Christ. So I'm in my final year. So the topic that I'm discussing today is automated single responsibility principle enforcement, a step towards reusable and maintainable code. So I'll be discussing about the introduction part, then majorly problem statement, objectives, and the methods that I have proposed. So starting with the introduction, design patterns actually was introduced decades ago to make the software codes more reusable and maintainable. But we know that as the software codes we have or different companies have been generating is becoming much more complex and really huge actually. So implementing design patterns in those software codes is actually very important as of now. So what this design patterns does is that it makes a software code more maintainable, reusable, and also it increases the quality of the code. So as of now, we don't have a automated tool to identify whether a software code is following a design pattern or not. Complete checking and all is done manually. So talking about the problem statement, so based on the literature that I have gone through, what I've identified is that even experienced developers as of now who are checking the design patterns in a software code, they find it very difficult to identify it. And most of the cases, they come to a wrong conclusion as well. So the reason why this happens is that the manual testing actually is done by analyzing the code structure, which actually does not capture the true intent behind the software code. And another thing is that if you take one design pattern, it can be implemented in multiple ways. That depends upon the developer who does it. So this also make it very difficult for the person who tests the design pattern in a software code. So my objective is actually to design a highly accurate design pattern detection algorithm. So I've actually prioritized more on the code metrics and class responsibilities rather than checking the code structure for identifying the design patterns. And also I have set up a set of common rules for a design pattern so that it makes it easier for developing an automated tool. So talking about the methodology that I have followed, so I have identified a particular design pattern and developed a set of rules for identifying it. And based on that, I've designed the algorithm and implemented it using Python programming language. And afterwards, I've done some sort of evaluation also to check for the efficiency of the code that I've developed. So I've actually focused on single responsibility principle. That's actually the first design pattern out of the 23. So the reason why I've chosen this, implementing an automated tool to check for the design patterns itself is actually a very complex task. So starting with a very complex design pattern it makes it much more complex. So I thought of just starting with the simple design pattern that is existing, and later on focusing on the other design patterns and work on it. So single responsibility principle actually tells like a class or module should only have a single task within it. It should not focus on multiple responsibilities. So an example that I've shown here, we have a class named student. So if you check out the functions that has been defined inside that, each of the function actually does different tasks. So this class actually does not follow the single responsibility principle. So the reason why we try to implement single responsibility principle in the software code is that it makes the code more modular, reusable, and also maintainable based on even if the software requirements are changing at different times, for the developers, it will be very easy to reuse the code or maintain the software codes. So talking about the rules that I have designed to check for the single responsibility principle. The first one is I'll be checking for the interfaces, whether the software code is using an interface or proper interfaces are implemented in it. Because like if we implement an interface in a particular software code, that actually makes the entire code more readable and maintainable as well. Because in interfaces, we define the tasks that need to be done, and each classes that needed to implement that task, they can just connect with that interfaces. So if we want to change the software code or make some changes in the software code based on the changing requirement, the only thing what we have to do is just change the interface where the actual task is being implemented. Later on, we can connect the different classes or modules with that particular interface. So first of all, I'll check whether the software codes maintain or they implement interfaces properly or not. Then I'll be checking for tight coupling between classes. Majorly, I'll be checking for data and control coupling. So coupling actually, it's actually the connection that is there between the different modules and classes in a particular software code. So this actually makes the high coupling actually makes it very difficult for changing or modifying the code independently. Because if you want to change a particular part of the code, if there is, a tight coupling has been there, is there in the code, we'll have to go through the entire code, change the entire code based on the requirement. So that actually make it less maintainable. So next I'll be checking for where there, if there is coupling and all existing in the software codes. Next rule I have developed is I'll be checking for the different complexity metrics. So one is cyclomatic complexity. That is actually a basic complexity checking method. So I'll be checking the entire cyclomatic complexity of the code. So if the complexity is very high, that also tells us that the entire code is not that we'll have to say maintainable, because the line of code is very huge. And also if we check for the complexity, cyclomatic complexity of each classes and all, if the classes are having high cyclomatic complexity, it means that it is having multiple tasks which has been defined in it. So I'll be checking for cyclomatic complexity. If the cyclomatic complexity of a particular class is higher, then I'll go for a little more deeper check. That is,
Excuse me, sir. Just a gentle reminder. 8 minutes are over. Can you please wrap up a bit quickly?
yeah, sure. So other thing I'm checking is Halstead volume and also cognitive complexity, and I'll check for maintainable index. So these are the rules that I have developed. So based on this, I'll come to a conclusion whether the software code is properly following the single responsibility principles or not. So this is actually a result, just some analysis part that I've done based on the each rules that I've developed. The correct predictions I got when I've checked for almost 25 code samples. Yeah, so one limitation that I found in my project is that as the complexity of the software code increases, the prediction accuracy for my the code that I've developed is getting slightly reduced. So it can be overcome by using machine learning and NLP techniques to get a high accurate predictions. Yeah, that's it.
Benjamin, actually, my question was that only कि single responsibility principle that you are developing will increase your code complexity that you have mentioned in last slide. Actually, you already have mentioned that limitation. So how, and you have said that the ML techniques and all will try to increase that accuracy. How you are thinking that it will increase the accuracy of the model that you want to develop?
So as of now, what I'm doing is a rule-based approach. So for me, there's a limitation to develop different rule kind of thing and also. But if I am implementing a ML or NLP technique, it can actually identify some or other features and patterns that existing in the particular code and get trained accordingly. So that I think it will increase the accuracy of the prediction.
But if we could have used the existing design patterns with all the predefined rules, then what do you think will be the accuracy like? And
I'm sorry, ma'am.
we are already having the various design pattern with the predefined rules and the tasks that they are going to perform, na?
Yeah.
So if we
So
could have used those tasks with the multiple responsibilities with the NLP techniques, then that could not be beneficial in that case.
Ma'am, as of now, the design patterns that are existing, for example, the single responsibility principle in itself, the rules that is existing as of now is that depends on the developers. We don't have a general set of rules to identify a particular design pattern. So it all depends upon the developer who tested. So if when he's going through a software code, if he, according to his perspective, if that code is like following the basic principle of this single responsibility principle, he'll come to a conclusion that, okay, it's this software code is following design patterns. Sometimes that may not be correct. So,
Okay. ठीक है, thank you.
Thank you, sir.
yeah,
Now we
thank you.
can move on to the next presentation. I'd like to call Mr. Vaibhav Lahane for his paper titled Comparative Analysis of Channel Estimation Techniques. Sir, can you please start your presentation, please?
Yes, am I audible?
Yes, sir.
Just a sec, I'm sharing my screen. Is it visible?
Yes, sir.
Good afternoon, everyone. First of all, thank you for giving me this opportunity to present at this conference. My name is Vaibhav Saudagar Lahane. I am a final year student at Pune Institute of Computer Technology. So today I will be presenting on my topic, comparative analysis of different channel estimation techniques. What is channel estimation? So channel estimation is a mechanism by which receiver determines the characteristics of channel through which a signal travels from transmitter to receiver. Using channel estimation, better detection of transmitted symbols can be done in dynamic channel with noise and interference. As we can see in adjacent figure, distortions occur by varying environmental conditions and obstacles due to reflection, diffraction, scattering, etc. There are three types of channel estimation: pilot-based channel estimation, blind channel estimation, and semi-blind channel estimation. So pilot-based channel estimation, in pilot-based channel estimation, a pilot sequence is used, which is known to both transmitter and receiver. And by using this pilot sequence as a reference, channel estimation can be done. Blind channel estimation. In blind channel estimation, it relies on statistical properties of transmitted and received signals. Blind techniques use information symbols to extract channel parameters. Semi-blind channel estimation. Semi-blind channel estimation uses combination of both pilot-based channel estimation techniques and blind channel estimation techniques. In our paper, we mainly focused on pilot-based channel estimation techniques. So there are four pilot-based channel estimation techniques: least square estimation, which is LSC; minimum mean squared error, MMSE; maximum likelihood estimation, MLE; and discrete spheroidal sequences, DPSS. In this table, we can see comparison of methods we discussed in above slide. Least square estimation, LSC, is the simplest technique, but it is more sensitive to noise and interference. It is used in Bluetooth and Wi-Fi. Minimum mean squared error, MMSE, is more accurate than least square estimation, and it is more resistant to noise and interference. Maximum likelihood estimation, MLE, is most accurate and optimal channel estimation technique. It is also very complex. It is used in wireless communication, radar, and satellite communication. DPSS. DPSS provides better performance in frequency selective fading channels. It is used in radar, astronomy, medical imaging, and channel estimation. So this is basic block diagram of channel estimation. The input data is modulated using a phase shift keying modulation technique. In here we used QPSK, which is quadrature phase shift keying. Then inverse Fourier transform of this data is done, and a cyclic prefix is added for OFDM. At receiver end, fast Fourier transform is taken, and channel matrix is estimated using different channel estimation techniques we discussed. This is okay. This is simulation of least square estimation for MIMO, one transmitter and one receiver. For this simulation, we took length of sequence to be 64 and varied noise variance and different number of transmitting and receiving antennas. Here, in this images, the blue symbols represent estimated symbols, and red symbols represent reference symbols. In first image, noise variance is 0.1. The estimated symbols are more closer to the reference symbol, and in second image, we can see like with increased noise, the estimated symbols are more dispersed. Also, the mean squared error for when noise variance is 0.2 is almost double when the noise variance is 0.1. Okay, here noise variance is kept constant, which is 0.2, and number of transmitting and receiver antennas is varied. The first image shows simulation for MIMO 2x2, that is two receiving antennas and two transmitters. And the second image shows for MIMO 3x3. As we can see, as we increase number of transmitter and receiver, the performance of channel estimation is increased. Here we compared simulation results of a least square estimation and MMSC. From this table and the graph, we can see that MMSC shows better performance than least square estimation. With this, I would like to conclude my presentation and thank you all.
In the channel estimation metrics, only these error noise parameters you have considered, or any other extra parameters related to security and all has been considered while doing this analysis?
Ma'am, we consider different parameters such as like I said, noise and variance, then average average power of channel, and no, ma'am, just these parameters.
For any specific application you want to give this type of estimation, or a generalized thing you want to tell?
Basically, we wanted to compare the existing channel estimation techniques like least square estimation, MMSC, and MLE. And our final year project is based on DPS's channel estimation. So we wanted to compare the performance of existing and the DPS's one.
Okay. Okay. Thank you.
Thank you, ma'am. Thank you, everyone.
Thank you, sir. Now we can move on to the next presentation. I'd like to call Mr. Aditya Kota for his paper titled Fire Detection, Harnessing the Power of Object Detection Algorithms for Advanced Visual Analysis. Sir, can you please start your presentation?
Hello.
Yes, sir, you're
Hello.
audible.
Oh, okay. Yeah. Sorry. Just a second. Is my screen visible?
Yes, sir.
Hello. Oh, okay. Thank you. So, good afternoon, everyone. Our topic is fire detection, harnessing the power of object detection algorithms for advanced visual analysis. I am a second year undergrad at Department of Electronics and Communication in Amrita Vishwavidyapeetham. So, the authors are Aditya Hegde Kota, myself, guided by Dr. Rajesh Kannan Megalingam and Avinash Hegde Kota. So the contents of this conference paper goes like this: the introduction, objective, dataset selection and pre-processing steps, system design and implementation, experiments and results, conclusion, future works and references. So while coming to the introduction part, the extensive research over 2 decades confirms the escalating severity and frequency of fires. The global warming primarily attributed to the increased incidence and severity of forest fires. This shows the urgent need to improve the strategies for forest fire detection and management. Some of the current forest fire detection and management systems are satellites equipped with infrared technology, scan vast landscapes for early detection, and ground-based sensor networks detect smoke and fire crackling sounds for rapid response, and drones equipped with heat sensing cameras for effective firefighting efforts. So the objective of this paper is to use object detection for fire detection. So the real-time object detection stays quite tricky because of differences in object sizes, shapes, inference speed, and noise. This gets even more critical for our scenario, as fire can swiftly shift position and change scale. It can rapidly go across the forest, etc. So there's a need for quick inference speed and rigorous model evaluation across various factors like consistency, object sizes, rotations, backgrounds, and aspect ratios. In this paper, we investigate the two major object detection algorithms, YOLO V8 and Pasha RCNN for real-time fire detection. So the data is collected from Kaggle and various sources like RoboFlow, comprising of 4,000 images of various forest fire images with 80% for training and 10% for validation and 10% for testing. There are two classes, fire and smoke. So in the pre-processing steps, auto orientation is applied on every image as real world data may contain varying orientations in images. So auto orientation helps the model for better accuracy and it ensures the consistency for feature extraction. filtering the images with no annotations applied. This step ensures the object detection algorithm has fewer false negatives and has enhanced performance. To address potential challenges in fire detection caused by variations in color such as different shades of red and yellow. Like fire has many colors. When dry leaf fires, it can be a reddish yellow. So to tackle these, we have specifically applied saturation adjustments within range of -20 to 20%, brightness modifications between 0 and 17%, and exposure alterations spanning -3 to 3%. This ensures model becomes more robust to color variations. The system design and implementation. We have implemented the nano version of YOLO V8, which has a backbone of modified CSP darknet 53, which is P5, and its head consisting of multiple convolutional layers followed by a series of fully connected layers. The input image undergoes processing through the modified CSP darknet 53 backbone. The primary structure involves the stacking of multiple C2 modules, each comprising two parallel gradient flow branches. In one branch, the input feature map is processed and returned as output, while in the other, a bottleneck executes conventional convolution, generating a new output feature map. The SPPF, the Spatial Pyramid Pooling Fusion mechanism, enhances the model ability to learn scale invariant features. This involves taking an input image and dividing it into grid cells. For each cell, a maximum pooling layer is applied with varying kernel sizes, and the resulting outputs are concatenated to form a unified picture representation. So in the head stage of YOLO V8, for bounding box related tasks, we use complete intersection over union and distributed focal loss for the box related tasks. And for the classification loss, we use binary cross entropy to classify things. And we use NMS non-max suppression for avoiding the bounding boxes with the IOU greater than the estimated one, which is 0.5 in our case. So the approach of training this YOLO V8 for the firstly, we annotated 500 images and trained it in the YOLO V8, and we used those pre-trained weights to annotate the next 3,500 images using RoboFlow. And we did this iteration. We did this in iterations. For every iteration, we just kept on increasing the data set. This made the model for better accuracy and faster RCNN. The faster region-based convolutional networks. Faster RCNN is a two-stage object detection system. In its first stage, it has RPN, and in the second stage, it has fast RCNN. So the two main components are backbone and fast RCNN. The faster RCNN, the features of input image are extracted using a ResNet 50 backbone. Following this, the RPN generates a bounding box of classes, also known as region of interest, based on the features obtained from the deep residual networks feature maps. The fast RCNN, which is the second stage of the faster RCNN, the ROIs identified in the first stage undergo a refinement process to achieve accurate object detection within an image. The ROIs are pooled to uniform size to ensure compatibility with faster RCNN detector. So the fully connected layers FC6 and FC7 perform two crucial tasks. One is predicting class probabilities and the other determining the precise coordinates of bounding boxes. So while doing this experiment, we achieved the results for YOLO V8, achieved the mean average precision of 79.8% at an IOU of 0.5 across all classes. Specifically for fire class, it has MAP of 82.6%, and for the smoke class, it demonstrated a MAP of 77. The model also attained an inference speed of approximately 81 frames per second. This performance aligns with the primary objective of achieving real-time fire detection. The faster RCNN showcased its capabilities by achieving mean average precision MAP of 68.6 across all object classes. So the conclusion is both YOLO V8 and faster RCNN have impressive performance, with YOLO V8 having a slight advantage in overall aspects. YOLO V8 is a leading choice for real-time application where both speed and accuracy detection is crucial. Faster RCNN has shown efficiency in the training phase. If fast inference and slightly higher accuracy are prioritized, YOLO V8 stands out. On the other hand, if rapid training speed is more important, faster RCNN emerges as an appealing alternative. Regardless of both models represent powerful tools in object detection landscape. So the future works we might involve combining thermal imaging with visual cameras to capture heat signatures even in low light or smoky conditions, and integrating weather data such as temperature, humidity, wind speed could improve contextual understanding and reduce false positives. So these are the references which we used, and thank you.
Aditya, you have used deep residual network. Can you tell me what is the advantage of using DRN?
Ma'am, deep residual network solves the problem of missing gradients, ma'am. Like when we train it on a large model, large data, it doesn't lose its gradients. It solves the vanishing gradient problem.
And what is this vanishing gradient problem?
So the vanishing gradient problem is when we train it on a majority of data set. So that when if it occurs any of two cases, like sorry, sir, when it gets on in one of two, which is which is saturation. Oh, sorry, which is
Okay.
data.
No issues, Aditya. Thank you.
Yeah, thank you.
Thank you, sir. Now we can move on to the next presentation. I'd like to call Mr. Ashish Nagila for his paper titled Machine Learning Method for Plant Leaf Disease for Improving Agricultural Production. Sir, can you please start now? Yes, sir.
Good afternoon, everyone. I am Ashish Nagila, PhD scholar, and today my topic is just actually there's some network issue. Good afternoon. My topic is machine learning methods for plant leaf disease for improving agriculture production. In my presentation, these are the topics which I have covered: introduction, lecture, literature review, objective of the study, methodology to be adopted, data set, experimental result, conclusion, and references. First, we start with introduction. In introduction, we can now meet the food needs of our society with the help of modern technology. However, we still have not gotten around to protecting our crops and food. In order to establishment of robust solution for these challenges is crucial. Utilizing technologies for solutions. Modern technologies such as advanced analysis and detection process can help address issues like plant disease. Comparison with the response to epidemic like COVID-19 highlights the dependency on technology to tackle agriculture challenges. Impacts of plant disease. Plant disease can lead to food shortage, deficiencies, and significant loss in farming, especially when done for profit. Role of machine learning and computer vision. Machine learning and computer vision often potential solution to avoid and manage disease in crops. The research aims to treat plant disease using machine learning through a three-steps approach. Number one, identify. Second is examine and verify with a database. Challenges in disease detection. These are the challenges. Various challenges delay the detection of plant disease, such as image quality, data availability, noise influencing results, segmentation difficulties, categorization issue, color variations, and the diversity of illness across different plants. This is the literature review, the paper which I have studied. Objective of the study. These are the objective of the study. Number one, development of a disease detection system. Designing and implementing a system capable of accurately identifying and diagnosing plant disease through the utilization of advanced technological tools.
Sir, can you please show your system architecture because your voice is not clear.
This is the methodology which I have used.
Can you please make it full screen?
The proposed model for detecting leaf disease using computer vision and machine learning is shown. The DWT, PCA, and GLCM are used to extract the informative features of the sample. In the next stage, as a
Sir,
part of
maybe you
machine learning
can
approach,
mute one of your accounts, like the one you're presenting can be mute so that the one you're talking, echo won't come.
the DWT, PCA, and GLCM are used to extract the informative features of the samples. In the next stage, as a part of machine learning approach, the KNN is used to classify the features and performance of the model is recorded. K-means clustering technique is applied on leaf images to find out the infected region. Discrete velvet transformation is applied on enhanced tomato sample to extract the useful feature. The DWT decomposes into sub-bands of lower LL, LH, HL, and higher frequency HH components. The LL components of DWT carries maximum ability of information when compared with higher frequency components of DWT as shown. Dataset. The analysis includes the plants affected by several illnesses as recorded in the tomato leaf village database. Tomato leaf with 6 different diseases are photographed so as to carry out the test for identifying leaf disease. Shows example of leaf image from the database. Experimental results and analysis. This is a confusion matrix. The model accuracy improves to 99%. Experimental results and analysis. The suggested model is compared to current approaches in the table below. Conclusion. Through the use of suggested model, this study has demonstrated a method for disease classification and identifications in tomato leaf. When it comes to accuracy, the proposed model achieves promising results close to 99% with the potential for an increase in the number of diseases in the future. This experiment does have certain restrictions. Future work on the model can focus on enhancing its feature extraction capabilities and expanding its testing to include additional datasets, leaf samples. These are the some references. Thank you.
Sir, in K-means clustering, how do you decide the value of K?
Ma'am, in most of the cases, the choice of K is usually 5 or 10. But there is
5 or
no
10?
formula, but there is no formula or rule, ma'am.
Okay. Answer in confusion matrix, what does the parameter precision specifies?
Yes, ma'am.
What does precision specifies, sir? What will you comment on the precision value after getting the result in the confusion matrix? Richa ma'am, I think there is some network issue again.
Okay, we can then move on to the next presentation. For the next presentation, I'd like to call Ms. Priyanka Patel for her paper titled NFT Marketplaces, the Revolution of Digital Ownership. Ma'am, can you please start your presentation?
Actually, on behalf of Dr. Priyanka Patel, I'm Chintan Kotaria, who's the author of paper I'm going to present.
Okay, sir.
Is my screen visible?
Yes, sir.
Okay. Good afternoon, everyone. My name is Chintan Kotaria, and I'm the author of paper called NFT Marketplaces, Revolutionizing Digital Ownership. This paper provides a comprehensive overview of the impact, functionality, and future role of NFTs in the digital ownership landscape. So today I'm going to talk about the impact of the NFT marketplaces, the functionality of NFT marketplaces, and the future role of NFTs. So moving on to the section 1, we will explore the foundational aspect of NFTs and their impact on the digital ownership landscape. This section will provide a comprehensive overview of the transformative role of NFTs. NFTs have emerged as a disruptive force, redefining digital assets, disrupting a traditional paradigm, and challenging established norms. They have created a dynamic environment at the intersection of technology, culture, and finance poised to reshape digital assets, interaction, and ownership. NFT marketplaces such as OpenSea, Rarible, and SuperRare have facilitated direct sales, royalties, and ownership rights through smart contracts, integration with blockchain, and decentralized verification, fostering trust and transparency. Impact of NFTs and their intersection with technology, culture, and finance. NFTs or non-fungible tokens have redefined digital assets and disrupted traditional paradigm, creating a dynamic environment at the forefront of digital ownership. In this section, we'll discuss about the different functionality of NFT marketplace and integration of NFTs with blockchain technology. This integration has been important in reshaping digital assets, interaction, and ownership, and we will explore its implication in this section. Uh, as we explore the creation and minting process of NFTs, it is essential to understand the technical aspects involved in the generation and management of these unique digital assets. The creation of NFTs begin with writing smart contracts, which are usually done by developer under development environment. These smart contracts are written in language like Solidity, which are optimized by the Ethereum network. These contracts provide each digital material a unique ID. The integration of NFTs with blockchain technology has been instrumental in ensuring secure and transparent transaction within NFT marketplaces, fostering trust and efficiency in digital ownership. The blockchain keeps all important data, including ownership and transaction history, to ensure the security and integrity of NFTs. NFT marketplaces leverage blockchain technology to provide decentralized verification of ownership and transaction history, ensuring the integrity and security of digital assets, and ensure that the record of NFT ownership and transactions are immutable, which will foster the trust and transparency in the marketplace. Furthermore, the role of smart contract in the NFT marketplace cannot be overstated. Smart contracts have facilitated direct sales, royalties, and ownership rights through secure and efficient transaction. Additionally, the diverse payment methods and mechanisms within NFT marketplaces have played a crucial role in enabling seamless transaction and ownership rights. Anyone can sell their asset on marketplace. All they have to do is provide a detail like title, description, and pricing while listing their assets. As marketplace is integrated with blockchain, all the information is kept on blockchain and linked with a unique ID. On the other hand, buyer can search and explore digital assets and begin the transaction either selecting buy or bid. As we move forward, we will delve into section 3, which will provide insights into the innovation and collaboration within the NFT landscape. This section will highlight the anticipated future role of NFTs and their potential application. In the near future, NFTs are anticipated to bridge the physical and digital worlds through virtual reality and augmented reality technologies. The future role of NFTs extend to emerging application in virtual fashion, metaverse experience, and iterative digital art transforming the way individuals interact with the digital content. This concept will close the bridge between the artist, brand, and technology companies, which will foster new form of digital expression. The NFTs are poised to expand beyond digital art and collectibles, encompassing the tokenization of real-world asset, intellectual property, and
Anand, what will you comment on the complexity of the system?
sorry, ma'am.
What will you comment on the complexity of the system that we are mentioning while transaction and all using blockchains?
Uh, the complexity is, I can say, is the medium complexity because whenever you are transaction one digital asset to a different account, there is one wallet that is necessary. To interact with that wallet, it's very easy. Anyone with normal knowledge of, you know, let's say GPay, anyone who uses GPay or any kind of application, they can use this wallet and make the transaction very easily.
Okay. But as the number of users grow, what about the time complexity then? Because
It
unless and
dep
until it is authorized by all the users, it will not be the legitimate one, like
yeah,
the
it
transaction.
as the number of users grow, that might be some kind of issues there.
Yeah,
Like a lot of what if lots of user don't approve,
authorize that block,
yeah,
maybe.
authorize that block,
Yeah.
and there might be a chance that that block is a legit one. That doesn't
Hmm.
have to be fraud or something like that. That's the issue, but that issue is very rare. We can say that it happened one in a billion or trillion times.
Okay.
So it's very rare to that issue to be occurred.
Okay. Okay. Thank you. Yeah.
Thank you, sir.
Yeah, thank you.
Moving on to our next presentation. I'd like to call Miss Rama Devi for the paper titled The Administration of Tangible Artificial Intelligence Systems. Ma'am, can you please start with your presentation? Um, I guess ma'am isn't available right now. We can move on to the next presentation till then. I'd like to call Ms. Vaishnavi M for her paper titled Traffic Optimization with AI-Powered Detection. Ma'am, can you please start with your presentation?
Yes, ma'am.
Ma'am, if you are facing any connectivity issues, then we can take on the next presentation till then. You can just message in the chat box. Okay, we can move on to the next presentation and then ma'am can come later. I'd like to call Mr. Harsivar Kandhari for his paper titled Vulnerability Detection and Assessment for SQL Injection, Cross-Site Scripting and Other Common Vulnerabilities. Sir, can you please start with your presentation?
Surely, sure. Just a second. Is my screen visible?
Yes, sir.
Okay, so my topic for the presentation is vulnerability detection and assessment for SQL injection, cross-site scripting, and other common vulnerabilities. I'm Hasima Kandari. I'm a final year student from Amity University, Noida. Now, first, we come to the need for just a sec. First, we need come to the need for this topic on this project and all. So basically, the world currently is greatly involved in digital activities. There are different digital activities that we use, plethora of activities like we use banking services, and the most common one is social media services. Whenever we use these services or do the activities there, some data is used or data is generated. This may also contain PII or personally identified information. If such type of data is lost or given to in wrong hands, it can lead to a lot of damages. These damages can be both financial in case of identity thefts, frauds, or some financial losses due to compliance issues, or it can be reputation losses. Like when we use a service and our data is lost, then we lose the trust in that service provider. So the main aim is to ensure that the host devices and web applications are secure. Now, a solution for it aims at providing methodology in which can help in detecting the vulnerabilities which can lead to these losses. Our solution has two parts. One is based for the endpoint security, and the other is based for the web security. On the side of endpoint security, our solution checks all the services that are used by the system and their versions and what common vulnerabilities are associated with them. And on the web security side, our system or solution checks if the web applications vulnerable to the various attacks. Currently, the solution works for SQL injection and cross-site scripting. Next, we have a literature review of some other related work in this field. There are many different methodologies that authors are used to did for these. For example, in the first one, the authors have used static analysis, runtime detection, and automation testing to check for it. They had few limitations like small sample size of hotspots, which are basically the sections of the web page which are to be tested. Other methods include mutation operators, which can be used to generate test cases. Another is to compare the intended query output size with the actual one which was observed. Another method which is used in the fourth paper involves checking the HTTP responses to our request and checking how it has affected it. And then we can also see there are many more methods. For example, in case of cross-site scripting, in the seventh part, they have a check for cross-site scripting using client-side request or server response using user-side proxy servers. And also there's another method you use first testing to exploit excesses. Now, main question arises, how does the solution differ from the ones mentioned before? So basically the solutions before used different methods like comparing the size of queries with actual one, checking the HTTP responses, and generating test cases to run for it. The way our solution differs is that we use the error detection to check for the errors which arise due to the improper syntax. Improper syntax basically in the way the database, the application interacts with the database, this improper syntax in syntax in those. Also, our solution also provides flexibility to select which vulnerability we need to check for, which can help in improving the performance of a solution. Now we come to the methodology. Firstly, there's the host-based vulnerability assessment. For this, our solution uses the Nmap Python module. This Nmap Python module basically helps us in detecting all the open ports and services and their versions which are being used by the endpoint. Then we link these findings with the CVE database, which is Common Vulnerabilities and Exposures database. This database is regularly updated and maintained by MITRE organization, and it contains detailed information about all the vulnerabilities and how they can be exploited. Now the question comes, how do we link the ports and the services to the database? And the method to do this is by using the URL given below. Basically in that URL is the URL to the database, online database of the MITRE CV database. And what we do is basically replace the last port name with all the services that we found in the endpoint. So for example, if we find a service for port 135, this is simply replaced in the last port name part to find the all vulnerabilities related to that. Next, we come to the application-based vulnerability assessment. Currently, there are only two types of attacks which have been tested for, which include SQL injection and cross-site scripting. When we come to SQL injection, our solution is based on error detection. So what it basically does is first it checks for the URL, gives the sample input of a quotes or double quotes to check if we input that in the URL, it generates an error or not. Next, our solution uses the request library to find all the HTML forms which are present in the app. Then it one by one it sends the test input like this single or double quotes to the web forms and checks if it generates any errors like the ones given on the right side. These are the basic errors which are being used by the system right now. The reason for using these errors to check for improper syntax is because one of the most common reasons for SQL injection vulnerability is that the improper syntax is used to check the database. In case of cross-site scripting, a little similar approach is used. In this also, we find all the forms which are present on the web app. Then we execute a JavaScript script in each of the forms. A sample script is given on the right side for the alert. If the script is able to be executed successfully, then we can know there's a simple, easy chance of cross-site scripting. Next, we come to the results which we found. So basically, we tested our solution for 5 different test sites. And for that, we checked if actually SQL injection was present, it was detected, and if cross-site scripting was present, and if it was detected or not. So in case of SQL injection, we find that out of 5 times, it was successful. The solution was successful 3 times. It was the only places it failed was in the third and fourth sites. So we had a SQL accuracy of almost 60%. Then we checked for cross-site scripting and we found that it only failed right now from the test site in the fourth part. So we can say in the present test scenario, it is 80%. Next, we have few screenshots of wait just a second. I just realized I was not in full screen. So these may be difficult to see. Now we have a few screenshots of basically the front end, the simple front end to check and how the output is displayed. On the left side, we have SQL injection. So for the test side, there were two forms detected on the site, and we can say the SQL injection vulnerability is possible there, and also the site name is given. In case of cross-site scripting detection, we checked it was detected. Then there are all on the site name is given at the below part, and also all the form details about the form are given. Next, we have the part for the host-based system. So when we click scan ports and give the input, like the basically local host or the system IP address, it checks for that and gives all the open services available, like port 135, 444, and 5500 is visible. Then when we click on any of these links, it leads to the CVE database to check all the possible exposures or vulnerabilities for that. Now we come to the challenges part. So first challenge is that currently the solution
Excuse me, sir. Just a gentle reminder that 8 minutes are over. Can you please wrap up?
Surely, just a minute.
Yep.
Only the one limitation is that we have the error set to check for SQL injection are small. Next is the amount of test sites we use are less. Another great challenge is that we check for many different system services. We have the need to devise a method to indicate which service can lead to a more serious vulnerability. Finally, the future work consists of increasing the data set of error statements, improving the accuracy and the performance of the system, the ability to detect more common types of vulnerabilities or attacks for the web app part, and finally, to add more test websites to improve the accuracy or to check the better accuracy. Finally, there are references which are of the related works that we have referred. Thank you.
Yeah, Harshivar, I was also saying that only that the cases that you have used for testing the vulnerable websites or not are too less actually.
Yes,
Based on
ma'am.
that, we can't tell the accuracy of our this thing
Yes,
projects.
ma'am. Yes, ma'am. The main
Yeah.
problem in this type of systems is that we have to find the test sites which are actually allow these, because whenever not all sites can be tested for it. So we are in the
Yeah, but if you
progress
want
of
to
checking
prove
for
the
more
test
sites.
accuracy, then we will have to use more number of websites. Then only you can comment on the performance of the system.
Yes, ma'am. That the accuracy is currently on the basis of those test sites. We are in the progress of finding more sites which can be tested. That's all.
Okay. And can you tell me what is the difference between the error-based and out of band-based techniques?
Ma'am, in error base, we are basically shown the errors. In out of band, we cannot. There is a kind of like blind attacks because we don't get the output from the output from the server. So we can those kind of out of band cases. It is a little difficult to check if it is actually had an effect or not. So in those cases, there are different types of methods used to check for it. Like we check for side channel techniques like the amounts, the output response time, and other things are checked to confirm if it had any effect or not.
Okay. Okay, thank you, Harshima.
Thank you, ma'am.
Okay, so moving on to the next presentation. I'd like to call Ms. Devangi Patel for the paper titled Advancement in Wheat Disease Detection, a comprehensive survey of techniques and challenges. Ma'am, can you please start your presentation?
Yes, ma'am. Thank you. Am I audible?
Yes, ma'am.
Okay. Myself, Devangi. Today I have presented Advancement in Wheat Disease Detection, a comprehensive survey of technique and challenges in International Conference ICTIS 2024. My co-author is Dr. Meghna Patel and Mr. Narendra Patel. Sir, these are content which I have covered in this presentation. Let's start with introduction. The agriculture sector is the main contributor to the Indian economy. According to the Economic Survey Report 2022-23, the agriculture growth rate has fallen to 3% in 2021 to 22 from 3.3% in 2020 to 21. Sustainable security in food and nutrition are major challenges in 21st century. In India, about the 70% of the population relies on agriculture. Wheat is the second largest crop in world, providing 19% of human calorie intake. Wheat disease affect wheat production, cause significant loss. Identification of the plant disease is important in order to prevent the losses within the yield. It is terribly troublesome to observe the wheat crop disease manually. So image processing and machine learning model can be employed for the detection of plant or crop disease. Next, AI technique used in agriculture sector. First one, image processing. Image processing refer to a set of technique used to manipulate and analyze digital image. It involves performing various operations on an image to enhance its quality, extract useful information, or interpret its content. Next, machine learning technique applied applications have been successfully developed worldwide for disease diagnosis. Machine learning algorithms exhibit both speed and accuracy in disease detection. Third one, deep learning. Deep learning is a subset of machine learning. Deep learning in agriculture involves using artificial neural network with multiple layers to analyze large data sets such as satellite imagery or sensor data for tasks like plant monitoring, disease detection, and yield prediction, aiding farmer in making data-driven decisions for improved productivity and sustainability. CNN in agriculture are used for tasks such as crop classification, disease detection, and yield prediction by analyzing satellite or drone imagery, enabling farmer to monitor crop health, detect pest or disease, and optimize farming practice for increased productivity and sustainability. Expert system in agriculture utilize domain-specific knowledge to provide farmer with personalized recommendation and decision support, aiding in tasks such as crop management, pest control, and irrigation scheduling for improved productivity and sustainability. Next one, AI technique for disease detection and classification used in agriculture. In the first one, image acquisition. Image acquisition in AI refer to the process of collecting digital images from various sources such as camera, sensor, or satellites, which are then used as a input data for training model. Second, image pre-processing in agriculture involves enhancing and preparing digital images of crops and field through techniques like noise removal, normalization, and contrast adjustment to improve the accuracy of subsequent analysis and decision-making processes. Third one, feature extraction in agriculture involve identifying and extracting relevant visual or spectral attributes from digital images of crop field, aiding in tasks such as disease detection, yield estimation, and crop classification. Fourth, plant disease classification in agriculture involve using machine learning techniques to accurately identify and categorize disease affecting crop based on symptom observing images or sensor data. And last technique is plant disease detection in agriculture involve utilizing image processing and machine learning method to automatically identify and diagnose disease affecting wheat crop on timely intervention. There are types of disease: white powdery, leaf rust, stripe rust, leaf blotch, head blight, and wheat blast. I have studied all paper which I have mentioned over here. First author review paper summarize the study of various automated tool, technique, and computation method used in different stages of wheat disease identification. This author used classification method. There some limitation. Author research on only parasite disease, not the non-parasite disease. Next author,
Devangi,
yes,
you have only written classification. Like here, you have mentioned CNN. So, which method is used here? You have not mentioned in this.
ma'am, I'm on learning stage, so I have referred this paper and I have find this technique only.
Okay. For what is the inference of this literature review? Can you show me in the next slide what inference you have drawn from doing this survey? Because after doing this survey, you have not mentioned like what all techniques you have found out for this disease detection, what all data sets have been used, what all evaluation metrics can be used for doing this kind of detection. All those things have not been mentioned, I think, na?
Yes, ma'am.
Yeah, so what means it is a suggestion if you
Yeah,
can accept this.
yeah,
When you do the survey now, then you should, after reading the paper, at least you should notify key what all techniques the various authors are using, what are the various data set on which they are performing, what are various evaluation metrics you can use for telling the performance of your model. So
yeah.
all these things should be analyzed while doing the survey, which will help you to come out to your problem statement.
Oh,
Yeah.
thank you, ma'am.
Thank you. Thank you. Yeah.
Thank you, ma'am, for such kind of information.
Yeah.
Yes, I will do definitely, madam.
Okay. Thank you.
Thank you, madam. Thank you, everyone.
Um, so moving on to the next presentation. Vaishnavi ma'am, you had internet issues earlier. So can you present right now?
Yes, ma'am. Am I audible now?
Yes.
Ma'am, am I audible now?
Yes, yes, ma'am. You can start.
Okay. Okay. Good afternoon, everyone. I am Vaishnavi. Now I am here to share my idea on the topic of traffic optimization with AI power detection. Now, let me give a simple introduction about my project. That is, traffic congestion is a significant issue in urban areas, leading to increased travel times, fuel consumption, and pollution. Traditional fixed-time traffic light control system often fail to adapt to dynamic traffic conditions, leading to congestions. Our project focuses on implementing an AI-powered traffic light control system, which switches the signals based on the density of vehicles in the single lane. Utilizing the YOLO algorithm for real-time vehicle detection, we aim to dynamically adjust signal timings based on traffic congestions, reducing waiting times, minimizing fuel consumption, controlling pollution, and enhancing overall system adaptability. And now coming to the objectives, to reduce traffic waiting time, it implements dynamic signal control to minimize intersectional delays. And next one, minimizing fuel consumption. This is to optimize flow to reduce fuel wastage and emissions during the waiting times in the traffic signals, and to control pollution by reducing congestion, aiming to lower the environmental impact of vehicles. And at last, enhancing the signal accessibility to improve the ease of use and accessibility of the traffic control system for better urban mobility. The scope and goal of this project aiming on, we are working on making city traffic better by using technology that can quickly understand and respond to what's happening on the roads. And our project supports three United Nations Sustainability Development Goals. That is to build better infrastructure and promote innovation, and to make cities more sustainable and livable, to take action against climatic change by reducing pollution from vehicles. Now, coming to the methodology of the proposed work, a problem identification and analysis, identifying challenges in urban traffic management, and to analyze current traffic condition and issues. Requirement analysis, and this aims on defining the technical requirements for the AI-powered traffic control system, and to specify the features and functionality needed for effective traffic optimization. And the system design is that designing the architecture of the traffic control system for the algorithm we have introduced, and to plan the integration of YOLO algorithm for real-time vehicle detection. And the software development aims on developing the software components for real-time analysis and signal control, such as connecting hardware components to NVIDIA kit, which we have used. And the integration and testing aims on integrating software components into a system to test the system accuracy, efficiency, and the reliability, and to deploy the system in real-time urban environment. And the methodology aims on gathering the traffic data using sensors and cameras installed at strategic locations. And the next step is utilizing YOLO-based object detection algorithm for real-time identification and tracking of vehicles, and to count the density of vehicles in the waiting lane, and to analyze the collected data to gain insights into traffic patterns, congestion levels, and flow dynamics. And the next part is developing algorithm to dynamically adjust signal timings, and to switch the signals based on traffic analyzing, and to optimize the traffic flow. And at last, evaluating the environmental impact to traffic management strategies to minimize negative effects. And these are the software and the hardware requirements for the idea I have developed. We have used the NVIDIA Nano Developer Kit as a controller between camera and the software. And we have used mini traffic signal modules for our live demonstration, and HD cameras for the detection of traffic signals. And the software side goes on Python programming language and OpenCV, and the libraries of TensorFlow. And we want RAM and storage space for running these process. This is the block diagram of our idea. We have connected these modules to the Jetson Nano Developer Kit, which is a microcontroller. And for a four-lane road, we have 4 different external cameras to be connected, and a Wi-Fi module and a power source. This is the project setup and the implementation that we have done. We have used 4 traffic modules, and based on the detection from the cameras, vehicle count is analyzed, and based on the count, the signal switching will be happening. And this is the output of vehicle count, and this is our developed system. Thank you. Thank you for listening.
So Vaishnavi, currently what data set you are using?
Ma'am, we are giving a real-time video for input, ma'am.
So you're directly taking the real-time video.
Yes, ma'am. Yes, ma'am.
Okay. And what is the accuracy that you are getting? Or the model performance?
Ma'am, the accuracy I have analyzed is that around 75%, ma'am.
Okay. On the prototype that you have developed, huh?
Yes, ma'am. Till now, prototype alone I have developed, ma'am.
Okay. Okay. ठीक है. Thank you, Vaishnav.
Thank you.
Thank you, ma'am. I sincerely thank our authors for this excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this 8th version and all the previous 7 versions of the conference. We will be happy to have you on the 9th version in 2025. All the presenters will be given their digital certificates via mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2024. I would also like to thank our session chair, uh, Rachna Sable ma'am. This is a token of appreciation from Global Research Foundation and ICTIS. Thank you, ma'am, for your valuable presence.
Thank you.
And before we end this session, I kindly request everyone to switch on the cameras for a quick snapshot. Thank you, everyone. Have a nice day.